Welcome to Unit 3, Two Variable Statistics, Lesson 7, the Correlation Coefficient. If you could take a moment and hit the subscribe button and give this a thumbs up to help other people find this information, I would greatly appreciate it. Our learning goal today is to see how good a linear model is for some data. We have two learning targets today. As we work through the practice problems, these are the things you should keep in the back of your mind and make sure that you notice when they come in on the practice problems. Make sure that by the end of the lesson you feel good making these statements, and if you don't, then please ask for clarification. If you're in my class, please use class time to ask for clarification. If you're somewhere else watching this, please leave a comment and I'll see if I can give you some clarification. The first learning target says I can describe the goodness of fit of a linear model using the correlation coefficient. So this is going to be a number, and based on what that number is, it's going to tell us how well the scatter plot data that we have actually fits the linear model that we're trying to use. Learning target number 2, I can match the correlation coefficient with a scatter plot and linear model. So the idea is, if you are given this correlation coefficient that we're going to talk about, and you are given different scatter plots and their lines of best fit, can you match that up? Do you understand what the correlation coefficient represents when it comes to a scatter plot and its line of best fit? So here we have this correlation coefficient that we're talking about. This is a number between -1 and 1 that describes the strength and direction of a linear association between two numerical variables. The sign of the correlation coefficient is the same as the sign of the slope of the best fit line. So we've talked about in previous lessons or maybe previous classes that you have a positive slope when you are moving from left to right if the line is going up, but you have a negative slope if when you're moving from left to right the line is going down. Well, the same thing applies here to the correlation coefficient. If you have a positive correlation coefficient somewhere between 0 and 1, then you know that the line is going up from left to right. But if you have a negative correlation coefficient, then you know that this line is trending downwards from left to right. The closer the correlation coefficient is to 0, the weaker the linear relationship. When the correlation coefficient is closer to 1 or -1, the linear model fits the data better. So we're talking about how spread out these scatter plot points are from the line. The closer it is to these points that are on the scatter plot looking like a straight line, the closer to 1 or -1 you're going to be. 1 if you're going up from left to right and they look really close to a line, or -1 if you're going down from left to right and the points look really close to the line. Now, as these scatter plot points start to spread out from each other, as in this middle picture they're giving to you, the closer you're going to be towards 0. So you might have a low positive decimal if it's going up from left to right, or you might have a low negative decimal close to 0 if it's going down from left to right in a general trend. So it says the first figure shows a correlation coefficient that is close to 1. These scatter plot points are very close to the line of best fit. It's almost making a 45-degree angle from left to right going up. Therefore, it's close to 1. The second picture here in the middle is still going up from left to right, but we can see that the points on the scatter plot are much more spread out. So a correlation coefficient for this would be further away from a 1 and closer to the 0 end. And then on the right, the third picture, we can see that the points are very close to the line of best fit. It's kind of making a 45-degree downward slope from left to right. And so this correlation coefficient would be somewhere near the -1 range. So make sure you understand the difference between what a 1 would look like, what something closer to a 0 would look like, and what something closer to a -1 would look like. So now we can begin on the Unit 3, Lesson 7 practice problems. On the first one, it says select all the values for R that indicate a positive slope for the line of best fit. So slope has the same sign as correlation coefficient. So if we want a positive slope, that means we need a positive correlation coefficient. And notice they're using the variable R. This is the common variable that we use to denote a correlation coefficient. So if you ever see R, that's what it is probably representing, is this correlation coefficient. So as we look through our answers, we want a positive slope, so we want a positive correlation coefficient. That would mean A, C, and F would be the positive correlation coefficients. If we have a negative correlation coefficient, then we would end up with a negative slope, and that's not what we want. And if we had a 0 correlation coefficient, we would end up with a 0 slope, or a sideways horizontal left to right slope, something like the x-axis. So if you have any questions about the relationship between positive slope, negative slope, or zero slope, and what type of correlation coefficient you would have, please ask for further clarification, and that way I can make sure that you are prepared as we move forward. All right, our next practice problem, the correlation coefficient R is given for several different data sets. Which value for R indicates the strongest correlation? So here's where we go back to that definition of correlation coefficient in the PowerPoint that we started with. Strongest correlation coefficients +1 or -1. Weakest correlation coefficient is 0. So if they want the strongest correlation, then we need to be as close to +1 or -1 as we can get. And as I look through my choices here, the closest one is D, -0.95. That is closer to -1 than any of the other choices are to +1 or -1. If you have any questions about this strength of correlation, please ask for clarification. Ensure that you understand the closer you are to a +1 or a -1, the closer you are to having the strongest correlation possible. The closer that you are to a 0, the weakest correlation you have. So our last practice problem for lesson 7, which of the values is the best estimate of the correlation coefficient for the line of best fit shown in the scatter plot? So the first thing that we need to notice, this is going up from left to right means a positive correlation coefficient. So when I look through my choices, I can immediately get rid of A and B. Those are negative correlation coefficients. This trend would be going down from left to right if it was negative. So now I just need to determine how spread out are these points from the line of best fit. If they're tight, like they are, so tight grouping around line of best fit means strong correlation near 1. So when I look at my choices, if my choices are between a 0.4 and a 0.9, I'm definitely going to choose the 0.9. These points are very closely grouped around that line of best fit. If you were to blur your eyes, you would see these points kind of blur together into a long black line. So therefore, we would say we have a strong positive correlation, and that would be D, 0.9 is our best option here. If you have any questions about correlation coefficients, please ask for clarification. Again, if you're in my class, please use class time. Get this clarification so that you're prepared before we move into lesson 8. If you happen to be watching this video somewhere else, you can leave a comment and I will try to get back to you with better clarification.